All right, so somewhere you're going to draw this picture and write linear pair. Two angles that share a wall and form a straight line. That's the definition. I also want you to have a second color out. So if you're using pencil, I don't care if it's a red pen, black pen, blue pen, highlighter, don't care. Because you're going to watch me do something. That is not where that goes. Oh, yeah, that is, but we're drawing this. Sorry, it wasn't wrong. We're doing this right now. Two angles that share a wall and form a straight line. So we're drawing this literally anywhere. This is not on that paper. All right, so share a wall. So is the wall that they share, is it the bottom or is it the line that's between them? The line that's between them. Some of you are getting confused what I mean by a wall. Okay, they have to be together like this with a line directly between them. All right? And then it says they form a straight line. So the part of that, the angles that are not what they share, this is your straight line, what we're going to be talking about. Okay? So later, I also want you to write this down and highlight this because you're going to have a classwork. And some of you are going to struggle with this. It's going to say, name two adjacent supplementary angles. Supplementary. Adjacent supplementary angles. So, guess what? This is another way to name the word linear pair. Because what does adjacent mean? They share a wall. Check. That's in the sentence we just drew. All right, and then it says supplementary. What does supplementary mean? They add up to what number? 180. What does a 100-degree angle look like? A straight line. So guess what? Share a wall and a straight line, that is the definition of a linear pair. So when you get to your classwork, when you literally have the second problem you do, and it says name a pair of adjacent supplementary angles, you're literally looking for a linear pair. Okay? All right. Going to keep going. Can anybody guess what this depicts? Okay, what 46 and 46, the angles across from each other, 134 and 134, what does this show us?
Angles.
They are angles, but what kind of angles? What? They are congruent, but of the kinds we learned yesterday. Not vertex, you're on the right track. They do share a vertex, that's it. What'd you say? Vertical, exactly, Tia. So vertical angles, that's what you want to write next. Vertical angles. And then I'll show you about them. Okay? Vertical angles. Here is your definition, and I will explain it. Vertical angles. Two angles that share a vertex are across from each other and are congruent. And then I wrote in all caps what to look for. Okay, look for two straight lines intersecting. So again, this is where that extra color will come into help, because if you're just writing all these dashes in one color, it's not going to help you color code which ones are congruent, which ones are the same, that kind of thing. So here's what we're talking about here. They share a vertex only. So if you look, 46 degrees and 46 degrees, that would be the left and the right, they're vertical to each other, okay? All they share is a vertex, meaning there's no wall that they share together. Do you see what I mean? Like 146 and 134, those share a wall. Whereas vertical angles will not. All they will literally do is touch each other by the vertex. Okay? It's like when, I don't know, y'all have seen The Lion King, right?
Of course not.
Y'all. Okay, when two little kitty cats, Miss Brown would love this. When two little kitty cats love each other, they touch their noses. You know what I'm talking about? So think of it. No? Okay, whatever. Vertical angles. Touch noses. Okay? What kind of cats do I said the Lion King. I'm sorry, I don't have a lion at my house.
You said cats, though, like kitty cats, which refers to.
Okay, like the little lion cubs, which I call kittens because they're little. What? We were, but he just made it confusing.
I thought she was talking about kitty.
They only touch vertices, okay? So, there's that. They're directly across from each other, and they are perfectly congruent. Look for two straight lines intersecting. So here's what that means. Remember that tool I showed you? That just draws a straight line? If I can't use that tool to draw a straight line, all right, so you're looking for where they intersect because it literally draws out where the two angles are, okay? Up and down, side to side. Those are going to be vertical to each other, all right? The last one are complementary angles. Go ahead and draw this. I drew this in particular so that you could see. So just find a place. We did this on the homework yesterday. I'll explain to you why they're still complementary. All of these angles are sitting on what? That's a line, a straight line. How many degrees is a straight line? 180. All right, so if we look at it, this line that's going straight up and it has a box, how many degrees are taken up on the right side? 90, because it's a right angle, get it? And then after that, what's left are how many degrees out of 180? 90, because what's 180 minus 90? 90, which would make these two complementary angles, okay? Because there's already 90 degrees taken up on the right side. The entire left side has to measure 90 degrees, okay? Which means these two added together make 90, okay? So, we're going to go to the first example in our notes. Yes, ma'am. All of them together are supplementary, but these two angles in and of themselves are complementary. All three of them together would be supplementary. How so? Pick a number between 1 and 90. 7, which would make this 83. All of them added together would make 180 degrees. But these two added together in specific add up to 90. That's all. All right, so flip to the front of your notes. Looks like this. I took this off of a worksheet. You should be able to answer the bullet points at the top, answering or asking questions. All right, under it says name two acute vertical angles. I told you to write this down just on the last slide. How do we identify vertical angles? What do we look for? Two lines intersecting. Two straight lines intersecting. So remember, lines go infinitely in both directions, yes? You remember that? So FD is a line that extends infinitely in both directions. How do we know that? What did it have on it? The arrows, which makes it extend infinitely in both directions. So does this line, EG, or EC, whatever you want to call it. AG, is that a line? No, what is it? It's a ray. All right, so, and then BG, also a ray. Okay, so we have outlined our two completely straight lines. So now we need to name the two acute vertical angles. The reason we outline these, and again, hopefully use a highlighter or something to outline what I'm doing. Mackenzie's doing it, that's perfect. The reason I'm saying this is because it literally shows us the four angles that are vertical. All right, acute means what? Perfect. They're less than 90. What'd you say?
The same thing below 90.
Yeah, anything below 90. Sorry, I thought you said blue. Anything below 90 degrees. So we have these two are vertical, and we have these two are vertical. Which of them look like they're less than 90 degrees? The red ones, I agree. So all we do is we name them. Let's name this angle on the left. When we name an angle, what comes first? The angle symbol. And then we can use, what did someone say? It's not G. F E. We could have also named it EGF. But G has to be in the center. What is the other vertical angle?
AGF.
CGD. You said AGF. So remember, vertical don't share a wall. Were you trying to name the green one? We're going to name that in a second for the obtuse. But we're naming the two acute ones, which are red. The obtuse are in green, so we wouldn't want to say AGF, because AGF would only include this slice of the pizza, if you will. Does that make sense? We want to include this whole side. All right, so we need to name those three letters. Can anybody take a guess what we would name it? FGC, I agree. FGC. FGC. All right, and then the other angle we call what? Yep, EGD. So we're naming this side. EGD. Ta-da! Those are our vertical angles. Who said O? Live with it. All right, next. Name a pair of adjacent angles. In order to do this, I'm just going to erase some things. If you have those highlighted, it's perfectly fine. There's no difference, and I'll highlight them anyways. Name a pair of adjacent. What does adjacent mean? Not just next to, but they share a wall. Okay? So, when they share a wall, literally pick any angle. Go. Pick one. FGE, sure. You're literally in my third class today, and everyone has picked this angle. I don't know why. But so anyways, this angle. So if we're naming this angle, we need to find an angle that is EGF. We need to find an angle that is adjacent, right next door to it. Okay, so it either shares this bottom portion or this top portion. Okay? Sure, we could say FGA. Angle FGA. Okay, notice how they overlap on this side. Okay, that's what makes them adjacent to each other. All right? What else could we have named? Just someone give me two angles.
EGZ.
CGD and what? You said CGD.
And EGD.
And EGD, correct? Or you could have said BGC. If I said AGB, we could say FGA. Or we could say BGC. Adjacent literally just means two angles directly next to each other. Okay? Questions on that one? All right. Obtuse. Name an obtuse angle. So remember that 90 degrees looks like a corner. So you need an angle that looks more than a corner.
EGD.
EG what? EGD, that sounds good.
AGD.
We could also say AGD, that's good. FGC, that sounds good. We could also say FGB, that's also good. BGE. Any of those that we just named, I'm just going to name one. Okay? All right, name a pair of complementary angles. This is still where students keep making mistakes. When you put on a pair of shoes, how many shoes are you putting on? Two. So when we're naming a pair of complementary angles, how many angles are we naming? Two angles. And what do those two angles come together to form? 90 degrees, which looks like a corner. So here's what's not on your picture that's supposed to be. That little box. So you want to draw that? I'm going to draw mine in black so you know that it was just supposed to be there, but when things get printed from Word, they don't always remain. All right, so name a pair of complementary angles. So they're two angles that make 90 degrees. So everyone agrees that AGE is a right angle, yes? But is it in itself complementary angles? No. Just by the grammar alone, no. Complementary angles are two angles that would make up this pink angle that I've drawn. Okay, so can anybody name the two angles that make AGE? EGF. Yep. EGF and angle, what do we say? FGA. That is correct. There's also a second set. Can anybody see them? A second set of... AGC is also a right angle. You guys are doing great. Because they sit on a straight line. If you look at the pink and the red, I know I'm off a little bit, but it's a straight line, which means if the left half is 90 degrees, that means the right half would also need 90 degrees. It's also cut up into two pieces, which means we could have named those as complementary as well. So angle AGB and angle BGC. All right, so we could have named either set of them. That's what?
That's crazy.
It is crazy. All right, and then the last thing, name an angle that is supplementary to FGE. So all I'm going to do is highlight FGE. All right, so supplementary means in a picture like this, if you're looking for supplementary angles, what does supplementary mean to me? It'll look like a straight line. It means they'll add up to 180, but do you have any numbers on the screen? No. Other than 10, 11, 12, 13, 14, 15. There are no degrees. So you can't just look at them and say, oh, these two add up to 180. So what you need to be looking for are what would make this angle and another make a straight line. So you want to look at, it's on this straight line. It's also on this straight line. Everyone see? So all you would do is you would name the other angle that would complete the straight line. I did it in red. So how would we name the one I just highlighted in red? EGD. There's also another answer to this.
FGC.
Exactly. If I highlighted the other straight line, okay, if you can see it, I know it's light blue. The other angle you could have named is indeed FGC. Angle FG. Sorry, it's not really colored over. C. Questions, comments, concerns? How are you doing, Jamari? You know, Spikes is a really cool last name.
That's what I said.
Isn't it? I'm a volleyball coach, so I mean, it's especially cool to me, but
How is it especially?
because girls spike. Well, boys spike too. All right, so two angles form a linear pair. You're on example 5. It's all the way at the bottom. What does a linear pair look like? A line with what?
Opposites.
I told y'all yesterday it looked like an upside down T. Do you remember? It also, hopefully you wrote it down. Look at Tia's. Look how beautiful, red and purple right there. It looks like that, give or take. We don't know exactly what it looks like, but if we draw, thank you. If we draw what it generally should look like, that helps us. Because how many of you are visual people? Because I certainly am. Okay, even if you're not, it still helps. All right, so on your paper, go ahead and draw that. Doesn't have to be perfect. All right, so after this, two angles form a linear pair. The measure of one angle is 5 times the measure of the other angle. So in order to know this, let's think about this real life. Who's the youngest person in this class?
That'd be me, Coach. His birthday is September. Oh, yeah,
Interesting. Jamari and Larson, I would guess you're the oldest? Okay, so let's say that Larson is, I don't know how old he is, but let's say Larson is 2 years older than Jamari. Whose age would we need to know first?
Jamari.
We need to know Jamari's, right? Because we referenced it back to Jamari's age. If we read this example, it says one of the angles is 5 times the measure of the other angle. So which angle would we actually need to know first?
The angle.
The other angle. Okay, so here's what you're going to do. One of these, because you're definitely going to have one of these problems on your quiz. I just printed it out this morning. Whenever it says the other angle, you're automatically going to call that angle X every single time. Okay, so go ahead and put that on your paper, X. Because if we don't know something in math, we always call it X. Is it still a math class? The measure of one angle, so that was the original angle, the one that we were referencing. One angle is 5 times. What does times usually mean? Multiplication. Multiplied times the measure of the other angle. So times the other angle. Just follow with me for a second. What did we call the other angle? X. So what does it look like when we multiply 5 times x? 5x. So here's what you know. One of the angles is 5x. The other angle is x. Okay, so do you follow? every single time you do a problem like this, where it is giving you 5 times or 2 times or half times, not half times, but half of the size, whatever, there's always going to be one angle that is x every single time. When students do this problem, because we're just going to keep doing it and doing it and doing it, when students do this problem, by the time they take their test, they forget about this x, which means they're going to get the wrong answer. Because you should have 2 references to 2 angles, because we have 2 angles here. Okay? What do we know about linear pairs? They're not opposite. They're on the same line. How many degrees is a straight line? 180. So how many degrees is a linear pair? 180. So these two add up and equal 180 degrees. So guess what we do? We add them up and set them equal to 180. Because linear pairs add up and equal 180. That's just the fact. From here, we use our algebra. What's 5x and x? 6x, which equals 180. Divide by 6, and x equals 30. So, look at that. What did x represent? The other angle. So look at that. We found one of them. Because we need to find the measure of each angle. We're finding 2 answers. So we found one of them. There are 2 ways to find the other. What do you think, Justin?
So you gotta do 30 minus 180.
Yeah, you could subtract. Okay? Or what do you think? You could also plug it in. The reason I would be more towards plugging it in is just in case you made a mistake. Does that make sense? So yes, we should still get the same answer. 5 times 30 is 150. So that means the measure of the other angle, the one angle, is 150. But had you subtracted 30 from 180, you still would have gotten 150. But again, if you made a mistake here, and then you subtracted, you would have 2 of them wrong instead of just 1 of them. Does that make sense? Yes, no, maybe so. Are you even listening to me? Maybe so. Questions on this problem? Shh, focus. All right, flip the page. We got one more to do together. Angle LMN and PQR are complementary. What does complementary mean for them? They add up and equal what? 90. So that means the measure of angle LMN and the measure of angle PQR will equal 90. So guess what? We have enough information to plug things in. What is the measure of LMN? 4x minus 2. So we plug in 4x minus 2. What's the measure of PQR? 9x plus 1. And they will equal 90. Is everyone okay with how we plug things in? Okay, so what do you think we do from here? We need to combine our terms, 9x and 4x, which make 13x. Minus 2 plus 1, minus 1. Add 1, 13x equals 91. What do we do from there? Divide by 13. I believe it'd be 7, yes? So x is 7. Did it ask for me to find x? No. It asked for me to find the measure of angle LMN and the measure of PQR. What was the measure of LMN at the beginning of the problem? 4x minus 2. So what do we do to figure it out? Plug it in. So 4 times 7, which is 28, minus 2 is 26. So by what Justin said, which I don't disagree, we should know generally what our next answer should be because it will be 90 minus 26. So our answer should be 64, but we got to plug it in just to check. So the measure of angle PQR, it was, 9x plus 1. So 9 times 7 is 63, plus 1 is 64. Do those two numbers add up to 90? Yes, they do. All right, from here we're going to open up our textbooks.